Alright, so for today, we are still doing trig ratio. So today's lesson is a continuation of the lesson from yesterday or the last topic. Alright, so yes, last time we talked about SOHCAHTOA. So let's do a quick review here first. First thing is SOHCAHTOA. They're here. We already worked out a few examples on the last lesson, so I'm not going to repeat myself. And indeed, you guys learned this last year, but just that you know that the SOHCAHTOA, they are here. That's the first thing that I hope you still remember. Second thing, yesterday or last lesson, we talked about CAS rule. So for different trig ratio, they are positive in certain quadrants and negative in other quadrants. So by applying the CAS, that will definitely help you to get the answer right. So C A S T CAS. So what does that mean? Everything is positive here. Only sine is positive. Everything else is negative. Only tangent is positive. Only cosine is positive. So that's the second thing. And then the third thing is, from now on, or as long as in this unit, make sure your graphing calculator is in degree mode. So I'm not going to repeat myself. Okay, so not degree mode yet. Go here. Okay, now it's in degree mode. If your calculator is not in degree mode, you screw up big time. I mean big time. Anyway, so now in the last lesson, we talked about setting up a right angle triangle and then apply the SOHCAHTOA thing. Then we can find, or we can use either way. Either use these to find others, or use these or find some of these. So x, y, and then the r is the length of the hypotenuse. Okay, so for today we go one step further. We will actually find the angle. Okay, how do we find that? By using the inverse trig function on your graphing calculator. So let's look at the example we did yesterday. Oh, you'll see in a second how CAS plays a big role in this unit, trig unit. So make sure you are aware of where the angle is, i.e. in which quadrant. Okay, so this is the example we did in the last lesson. You can either look at the notes from last day, and what I'm going to do is I'm going to work this out again. Assume we have never done this before. I hope you can pause for a few minutes and then finish this all by yourself. Hopefully you can get everything right. Alright, so let's do this. So we have a point P, -8 and 15 on the terminal arm. So let's draw this first. So -8 and 15. So that means it is in quadrant 2. So this is point P, -8 and 15. And of course, this makes up a right angle triangle, and then your angle theta is this. Alright, and then we apply the coordinate to find the length. So if you look at this, -8. So guys, as we mentioned before, this is the length, so there's no sign with it. The length here is 8 units. But in order to keep track of the sign so that we do not screw up the SOHCAHTOA thing, we still keep track of the sign. So -8 here, 15. So this is your R, and of course we know we are going to find it. So we're going to apply the Pythagorean theorem. So we did this one yesterday or last day, so I'm going to go a bit fast. So a squared plus b squared equals c squared. So 15 squared plus -8 squared equals to r squared. And then 15 squared is 225. -8 squared gives you 64. That gives you r squared. and then 225 plus 64, that gives you 289 equals r squared. And then of course you take the square root on both sides so that you can just find out. And if you take the square root of 289, that gives you 17. Okay, so that gives you 17 here. No big deal. Alright, so now we can quickly set up the trig ratio. We can do sine, cosine, tangent. Let's move this. Let's quickly set this up here. So for sine, it is opposite over hypotenuse, opposite over hypotenuse. Okay, and then for cosine, adjacent over hypotenuse, -8 over 17, and then tangent, opposite over adjacent. Okay, so that's what we did yesterday. Now we go to the next step. By setting up these trig ratios, how can we use those to find the angles? So you do the inverse function. So let me show you the work first. Start off with this one. To find the actual angle, angle theta, you do the inverse function. So you do the inverse sign here. This is the inverse of whatever number or the ratio that we figured out. Okay, so graphing calculator, we already changed the setting to degree mode, so we'll just start from there. Now we are going to do the inverse sine. How do we do the inverse sine? Look at this. Inverse sine, inverse cosine, inverse tangent, inverse sine, and then we enter the ratio 15 divided by 17, close bracket, enter. Oops, I screwed up, sorry. I didn't hit this function button. So second sine 15 divided by 17, close bracket, enter. So here we go. If you round it to the nearest degree, that means this is 62 degrees. So that means this is 62 degrees. Okay, so let's do this one here. How do I use this trig ratio cos to find the angle? So you do the inverse. So we are talking about cos here. So inverse of cos of, in this case, -8 over 17. Okay, so let's do it on your graphing calculator. Inverse cos, which gives you this. Okay, and then we have -8 divided by 17, close bracket, enter. So that gives you, in this case, once again, we are rounding it to the nearest degree. So that gives you 118 degrees. So 118 degrees. So now I hope you can finish this by yourself. You might want to pause for a few seconds. Anyways, inverse 10 of the ratio for this one, 15 over -8. So inverse 10 -15 divided by 8, close bracket, enter. That gives you -62 degrees. Okay, so -62 degrees. I hope this new, I don't know if you guys learned this last year or not, but I don't care. So I hope this is not too bad if this is the first time you ever learned this, using a trig ratio to find the angle. Now I would like you guys to check out these numbers for angle theta. Did you guys see something? You might want to pause for a few seconds. Okay, so I hope you guys saw something or realized there is something strange going on. We derive all these trig ratios using the same setup. There's okay? And all these angle theta refer to this. But when you look at the actual value, if you're using sine to find the angle, that gives you 60 degrees. If you're using cosine to find the angle, that gives you 118 degrees. If you're using tangent to find the angle, that gives you negative 62 degrees. Wait a second, we are talking about the same angle. How come these numbers are not the same? And even worse, they are all over the places. Remember what we briefly reviewed from last day's lesson? There's something called the CAS rule. If you look at this, each trig ratio is positive in certain quadrant and negative in other quadrants. So if you look at this hopefully makes sense if you consider the CAS. So if you look at this, sine is positive. When is sine positive? Of course, in quadrant 1, that's why look at this angle. It's referring to an angle in quadrant 1. Of course, you would say that sine is positive in quadrant 2, but let's just look at this. We'll talk about why your calculator only mentioned this angle here in quadrant 1 but not in quadrant 2 in a second, but I hope you can see what's going on here. Now next, cos is negative. So if you apply CAS rule, cosine is negative in quadrant 2. That's why look at this angle here. It is an angle in quadrant 2. If you apply the same concept here, so in this case for tangent, tangent is negative. So tangent is negative in quadrant 4 and quadrant 2, but your calculator showed you this in quadrant 4. So I hope when you look at this, it makes sense because tangent is negative in quadrant 4. That's why you have negative 62. 0 here going clockwise, that gives you a negative angle measurement. Now let's look at what's going on here. Why does the calculator do this? So let me give you the answer first. Because your calculator would take into account CAS and also referencing to 0 degrees. So that means CAS, okay, and also referencing the 0 degrees means this is the starting point. Okay, so if it still doesn't make sense, I will quickly do this here to help you visualize this. Oops. To help you visualize this and also show you something fascinating. All right, so let me just bring all this down here. How come your calculator would do something like this? As I mentioned, CAS and referencing the 0. So now let's look at this here. Let's look at the first scenario. If you have something like this, sine theta is 15 over 17. So let's sketch this here to help you visualize what's going on. This is our original drawing. And then if you look at this, sine is opposite, which is 15 here. Oops, wrong color. Over hypotenuse. Okay? But believe it or not, there is another way to draw this. When it says a height of 15 and a length for the hypotenuse is 17, you can also sketch it this way. Oh my, this is annoying. Oh my god. 15 and 17. This is super annoying. Okay, now if you just look at this new triangle that I just drew and apply the cast rule, you get the same answer. And of course, this is your angle theta. So now if you look at this, you have two different types of angle here. One is an acute, one is an obtuse. So now when you do this, your calculator doesn't know which one you are talking about. What it does is using the reference angle and did the calculation. Because both ways are valid, that's why you would end up with the same answer. If you don't know what I'm talking about, let's do this. You'll see some amazing thing. So let's do this. From above, we figured out that if you're using sine, that will give you 62 degrees to give you this ratio. So let's do this. Sine 62 degrees. Quickly punch that in your calculator. Sine 62, sine 62, close bracket, enter. That gives you 0.8829 something. 0.8829 something. Now, if you look at this, we figure out that it is 62 degrees. So if we do the reference angle, if this is 62, that means this is also 62. If you take away 62 from 180, so that means the angle here would be 118. So what's the big deal? Let's do this. Sine 118 degrees. Sine 118 degrees. Now look at this. These two are different angles. 62, 118, but they have the same reference angle. Reference angle here, quadrant 1 from yesterday or from last day, 60 degrees. Reference angle here is also 60 degrees. Check this out. They give you the same value. So that's why when we did the calculation here, your calculator doesn't know whether you're talking about this acute angle or obtuse angle, because it will give you the same number anyway. So it gives you 0.8829, exact same value. I'll do one more here, and then you can figure out the tangent. So if you look at this, let's look at cos here. Same thing. Let's use the same setup. And then same thing. Adjacent hypotenuse. So that's -8, and the hypotenuse is 17. Okay, however, just like the last one for sine, we can have more than one way to draw this. You can use the same set of information to draw the exact same triangle in a different quadrant. So if our adjacent is -8, so -8, we can also draw a triangle like this. This is still the adjacent. Okay, but then our angle theta would be this. And we also have the hypotenuse of with a length of 17, like this. So now look at this. Adjacent, -8, hypotenuse, 17. Okay, so if you look at this, The original angle using cos that we found was 118. So let's do this. Cos 118. Let's do this here. Clear all this. Cos 118. Enter. That gives you negative 0.469. Negative 0.469 dot dot dot. Now if you look at this, so 118 degrees, so that means your reference angle is 180 minus 118, so that means this reference angle is 60 degrees. The reference angle for this green one is 60 degrees, but then what's the angle theta of this whole thing? 180 plus 62. That gives you 242 degrees. Now if you enter cos 242 in your graphing calculator, cos 242, it gives you the same value. Again, your calculator is smart enough to use the cast and also look at the reference angle, but it is still but enough to confuse you. So look at this, exact same value here. Even though these two angles, they are totally different values. Okay, so that gives you 0.469 exact. Okay, so you can have some fun figuring out this with tangent. You'll find that if you do tangent negative 62, it gives you one number, and then if you do tangent 118, it gives you exact same number. Alright, because tangent is negative in two quadrants. Anyway, next, let's talk about the special case triangles. Why do we want to talk about that if we can use our graphing calculator to find all the trig ratio? Well, if you look at this, it says exact. Oh, I don't want that, I want. So in this case, we are not talking about approximation. If you're lucky enough to get something like 0.5, that's the same as 1/2, no big deal. But then using a class example, I've always been mentioning in class. So if you have 1/3, it is wrong for you to put down 0.3. 0.33 is also wrong. 0.333 is also wrong because exact means exact, no approximation. So for the things I'm going to do in the following, that will give you an exact value. Alright, so let's do this and then we will come up with some generalization. So there are two special cases we are going to look at. First one, when we say special cases, we are going to make life easy, a little bit easy for you. We are just talking about two different scenarios: 90 degrees, 45 and 45, 90, 60, 30. Okay, so only these two. So if you look at this, let's do this. If you have a triangle with 90 degrees, 45, 45, this is an isosceles triangle. What does that mean? The length of this side is the same as the length of this side. And this is 45 degrees, and this is also 45 degrees. Okay, so again, we can do the Pythagorean, because this is a right angle triangle. So a squared plus b squared gives you c squared. So if you want, we can keep it consistent, call this r. So 1 square plus 1 square equals to r square. 1 square is 1, 1 plus 1 square is 1, r square. And then that means 2 is equal to r square, and that by taking the square root, so that means r is equal to the square root of 2. So root 2 here. Now, opposite, adjacent, hypotenuse. I'll quickly work this one out with you guys, and then you can figure out the other one. I'll just briefly go over that. So in this case, if you look at this, sine 45 degrees. Let's say we are looking at this as my angle theta. Okay, then I have my opposite adjacent hypotenuse. So we can set up the ratio sine opposite over hypotenuse. So 1 over root 2. You can quickly figure out the rest. I'll just copy them down here. I mean write them down here, not copy. So cos adjacent over hypotenuse. So that gives you the same thing. Adjacent over hypotenuse. And then last one, tangent theta. Instead of saying theta, we know what our angle theta is, which is 45 degrees. So opposite over adjacent, opposite over adjacent, which is 1 over 1, and that's 1. Okay, now let's look at a second scenario when we have 90 degrees, 60 degrees, and 30 degrees. Okay, so this one we have obviously, okay, 90, 60, 30. Obviously, this is the 90 degrees. So our angle theta could either be 60 or 30. So I'm going to put down 60 here and 30 here, and then 30. Some of you may say, Chang, why didn't you put down 30 here and 60 here instead? Well, we will get to that. That's our next one here. Okay, so now if you look at this, half of an equilateral triangle with side lengths of 2 units. So 2, 2, and 2, because this is equilateral triangle. So that means the length of all the sides are the same. And because this is half of the whole length, so that means this is 1 here. Okay, so keep in mind at this point, I am using this as my reference angle, angle theta. So if you look at this, same thing, let's find the height here. Right? So the height, well, let's keep it consistent. Horizontal, the width x, the height y, hypotenuse r. So this is my y. We figured that out. Okay, so if you look at this, I'll do it quick here. Once again, this is Pythagorean. Alright, so 1 square, I'm looking at just this triangle, just this. 1 square plus y square equals to 2 square. So 1 square is 1, y square is still y, and then 2 square is 4. So y square gives you 3, and then y, take the square root of that, gives you root of 3. Now I know the length here, so now I know everything. Opposite, adjacent, hypotenuse. So let's do the SOHCAHTOA thing. So in this case, instead of saying sine theta, we know the angle is 60. As I said, we'll deal with a 30 in a second. So quickly do that. So sine is opposite over hypotenuse. So root 3 over 2. Root 3 over 2. So I'm not going to go for cos and tan with you. I'll just quickly write it down for you. Cos is adjacent over hypotenuse, so that gives you 1/2. And then for tangent, opposite over adjacent, that gives you root 3 over 1, which is root 3. Okay, now let's move on to the one below here. Since we are talking about the same triangle, except this time we are going to use the 30 degrees as the reference angle. So if you just rotate this 90 degrees clockwise, then we will have something like this. The length here just for this part is 1. The length here of this side is still 2. This is 60 degrees and this is 30 degrees, and I know that the length here is root 3, and this time my reference angle is, the angle I'm referring to is 30 degrees. Alright, so quick, a few seconds. Opposite, adjacent, hypotenuse. And I'm referencing to the 30 degrees here. So quick, a few seconds. Alright, so in this case, well, I'll just write down the answers for you. So opposite over hypotenuse, that's 1 over 2, 1/2. Alright, cosine is root 3 over 2. Tangent is 1 over root 3. Now we can use these triangles to solve for angles or ratios when we have a reference angle of 30, 45, and 60 degrees. Don't worry, you don't have to memorize all these numbers. No, not all this. Indeed, if you are quotation marks fortunate enough to have me for Math 30-1, I will show you a quick way to memorize all these numbers. But even if not, you don't have to memorize all this. Instead, I'm going to show you this. I'm not going to teach you a shortcut method because otherwise you wouldn't pay too much attention here. So let's set it up this way. So we have two scenarios. First scenario, when we have 90 degrees, 45 degrees, and 45 degrees. If you want, you can jump down degrees. And then second scenario is 90, 60, 30. Second scenario, 90, 60, 30. So these are the angles. And what we are going to look at, or what you need to learn, remember, memorize, is the length. So if you can remember the length of the side corresponding to that angle or opposite to that angle, then you can simply use those and then figure out all these numbers. Sorry, not numbers, but all these exact values. Exact. This one you can cheat by using a graphing calculator. So cos 60 gives you 1/2, no big deal. But what about this? If you do it on your graphing calculator, sine 60, oh, sorry, not sine, yeah, sine 60, sine 60, what is the exact value? What kind of fraction would give you this number? You better remember, learn, memorize what I'm showing you here. You can memorize that, oh, 60 degrees, sorry, sine 60 degrees is root 3 over 2, but then there's so many things like that. You have 3, another 3, another 3, 9 numbers to remember. Okay? So anyway, so if you look at the 90, 45, 45, the side opposite to the 90 is 2. The side up, oh, sorry, not this one. The side opposite to 90 degrees is root 2. The side opposite to 45 degrees is 1. And same thing here. So that means the length of the side are, nope, root 2, 1, and 1. Okay? We will work out examples, of course, after this and see how it works. Okay? Now this one, 90, 60, 30. The side opposite to the 90 degree has a length of 2. The side opposite to the 60 degree, doesn't matter which one you look at, 60 degree is root 3. 60 root 3. Same thing here, 60 root 3. Root 3. And then the length of the side opposite to 30 degrees is 1, 1. Okay, so this is not on your formula sheet, so you better memorize that, or somehow if you can memorize this result. If you know anyone who took Math 30-1 already, you might want to ask them the trick. Okay, even for my own 30-1, we are not there. We are not in the trig unit yet. Okay.